we are going to work or deal with chemical equilibrium. Chemical equilibrium is the basic concept that each and every one of us should be able to get maximum marks. But the biggest challenge with chemical equilibrium is when we get to the graphs. So what I am going to do now is I'm going to explain concepts of Le Chatelier, factors affecting the chemical equilibrium, the KC approach, and do a little bit of problems related to that. Tomorrow then we work only on graphs, because the graphs also has a greater influence in terms of how we approach the questions as well. So today the intention is we'll go up to 8 o'clock only to focus on the key critical basic things that one needs to look for. So with that being said, ladies and gentlemen, let me get straight into it. There are critical definitions that one must know. The very first one is what is now a reversible reaction. So a reversible reaction is a reaction in which the products can be converted back to the reactants. So this is now one of the key critical definitions that one must know. It's the reaction in which the products can be converted back to the reactants. That is very important. How do we indicate that now a reaction is reversible? The very first thing that one must look for is to actually ensure that now we look for the double arrows there. So the double arrows will actually indicate that now this reaction is indeed reversible. So once you see double arrows, it is reversible. Then possible question is define reversible reaction. So reversible reaction is a reaction in which now products can be converted back to the reactants. That is very important. But now we also associate, I will come to closed system. We also associate chemical equilibrium with what? With what we call a dynamic equilibrium. Now, when one explains what is a dynamic equilibrium, it can only be dynamic because of what? Because of now the rate of the forward reaction is equals to the rate of the reverse. This is now a critical definition that one must know. It further says the amount of reactants and the amount of products remain constant. Ladies and gentlemen, I must say, we do not accept bullet number 2 in this instance. It basically says if it is in equilibrium, the rate of the forward reaction is equals to the rate of the reverse reaction. We do not now expect you to give a definition of what? Of dynamic equilibrium by focusing on the amount of reactants and the amount of products. We are interested in the rate of the forward reaction must be equal to the rate of the reverse reaction. So this is now a critical point number 2 that one needs now to be looking into, to be focusing into, because obviously the definitions will be part of the question paper. The majority of the marks will be on the Le Chatelier, the KC, or even a graph thereof. But now we need to actually focus on the important critical definitions. The other one is now a closed system. A closed system is a system in which only exchanges energy, not matter, with its surroundings. So also that is now another important definition that one must know. Of what? Closed system. So a closed system is a system in which only exchanges energy, not matter, with its surroundings. You will see I've added another slide here such that you can be able to understand how does now this closed system actually influences the equilibrium itself. Furthermore, we have factors that now affect chemical equilibrium. The factors that affect chemical equilibrium, one must highlight. Now I'm going to make this one number 4. A catalyst has no effect on the equilibrium position. It only shortens the time it takes to reach the equilibrium. So what does it do? It basically increases the rate of reaction. It does not affect chemical equilibrium. That is very, very important. So what does this say to me? It says whenever I am given a catalyst, it basically says the amount of reactants and the amount of products will be the same. Why? Because it does not have now an effect on the equilibrium position. But the examiners are going to expect us to explain these factors that affect chemical equilibrium in terms of the principle of Le Chatelier. Previously, it was expected of us now to apply only, but recently you apply, okay, it's best to say we state, and B, we apply. Because I have seen a question where we're asked now to state the Le Chatelier's principle. So we must be able to state and apply. But that will come later when we are expected to use the Le Chatelier's principle, because the examiner is going to say now use the Le Chatelier's principle to actually explain the shift in equilibrium. When the equilibrium in a closed system is disturbed, the system will reinstate a new equilibrium by favoring the reaction that opposes the disturbance. So if you increase the temperature, the system will try to decrease. If you add more of the reactants, the system will try to decrease. So basically, Le Chatelier says whatever you disturb in the system, Le Chatelier or the principle itself is going to try and do what? To oppose the disturbance. So what can be a disturbance in this instance? Disturbance, ladies and gentlemen, can be anything. But basically, it is just now increase or decrease of a certain factor. You add more of reactants, you add more of products, what will happen? That is what now Le Chatelier is interested on. So the system will always try to reinstate. Reinstate basically means to try and now establish a new equilibrium. So in this instance, be on the lookout to state and also apply. Furthermore, the factors that now affect chemical equilibrium is concentration, let me make it 5, is temperature 6, and pressure 7. Now the confusion comes when we have rates of reaction, concentration, and temperature. surface area, and a catalyst. So people want to associate pressure also with rate of reaction. That is not acceptable. That is not applicable. Pressure will only be a factor that only influences the chemical equilibrium. So be on the lookout for not to fall on the trap of thinking that pressure now is going to be part of rates of reactions. That's the reason why I said now, how about we have an analogy here of CPT for Cape Town. This is now concentration, pressure, and temperature for equilibrium. But now what about the ones of rate? Is concentration, its surface area, and its temperature. So you can create your own nice analogy with that, such that now we do not confuse the two. Though, so the CPT is when I come to chemical, the C for concentration also. It's now referring to me to say, but now I am only going to focus on chemical equilibrium. Furthermore, it says predict and explain the effect of equilibrium or on the equilibrium. That is the Le Chatelier's principle. Let's check. Let's start with concentration. Like I said, this is basic, easy way of answering these particular questions. Why? Because if one is in a position of ensuring that you understand or you have picked up which factor is actually being assessed by the examiner, it's easy to apply the Le Chatelier's principle because there are bullets that one must follow. Now let's check. Like I did say, disturbance can only mean increase or decrease. Catalyst, no effect on the chemical equilibrium. Let's start with concentration. Concentration, if we increase concentration, reaction that decreases the concentration is favored. If we decrease the concentration, a reaction that increases the concentration is favored. What is the meaning of this? The meaning of this basically says we need to look into which factor is being disturbed. Is it a reactant? Is it a product? Then we can be able to say, but now if we are decreasing the reactant, it means now we need to be in a position of decreasing that particular reactant. So a reaction that will decrease that is the one that will be favored. But it will be clear once we work with now what the actual questions in an exam for us to be able to see that. An example is given here. And remember, concentration is for only gases as well as aqueous solutions. So once I see a solid, it means that solid will not be part of any calculation that I'm going to perform. That solid is maybe going to assist me only to get into a point of using the ratios thereof. But on my calculation, my explanation of Le Chatelier's principle, it's not going to assist, it's not going to work. Why? Because a solid does not have now concentration. If we increase H2, forward reaction is favored to decrease H2. Why? Because we did say that now if you increase the reactants. It basically says the reaction will try, or the system will try now to decrease that. How do we decrease the reactants? By forming the products. Which reaction forms the products? As the forward reaction. Then we will be in a position to say the concentration of H2 will decrease, a forward reaction will be favored, and then it means now more of H2S will be formed. But that now will come when we explain the Le Chatelier's principle in detail. Furthermore, it says now H2 is decreased. If we decrease now H2, what will the system try to do? The system will try to increase that particular concentration. So how do we increase the concentration of the reactants? Is by allowing the reaction to move to the reverse. So if it moves now to the reverse, it basically says we are going to have an increase in the concentration of the reactants. And now what about H2S? The H2S will now decrease because the reverse reaction is the one that is actually favored. If I have now H2S that is increasing, that is now the product in this instance. If the product is increasing, what will happen? The system will try to decrease that particular product. So how can we decrease a product? It's by forming more of now what? The reactants. So if I want to form more of the reactants, it means the reverse reaction must be favored. So when we apply Le Chatelier's principle, these are keywords that now examiners are looking for. The disturbance, which is now either increase or decrease. Which reaction is favored? How will that reaction now influence the concentration of either the reactants or products that are being assessed? Furthermore, what will now be the yield in terms of the factor itself? So I'm going to pause there, give you 30 seconds, such that now immediately after 30 seconds we can go into the temperature and pressure, and then further explain other important concepts. Any questions, ladies and gentlemen, relating now to the factor, which is concentration? You can raise your hand, feel free. I will now attend to your questions immediately after the 30 seconds. Thank you very much. I don't see any hands. It basically says now the explanation is straightforward and clear. Let's go to temperature. We said a disturbance can be increased or decreased. So in this instance, when we increase temperature, endothermic reaction is favored. I have included a slide as to how can one now know, or the hint that examiners can give, or a different ways of one understanding or picking up if we are told that now the reaction is endothermic or the reaction is exothermic. With temperature, ladies and gentlemen, there is no way you can answer that particular question of the factor of temperature without actually knowing whether the reaction is endothermic or exothermic. But now I want to highlight here this delta H is for the forward reaction. That is very, very, very important. So they can give you any information that indicates that the reaction is either exothermic or endothermic, but that will be now only because of what? The forward reaction, or the delta H, or the information given will basically be the one that represents the forward reaction. So if the forward reaction is endothermic, if the forward reaction is endothermic, it basically says now the reverse must be exothermic and vice versa. That is very, very critical for one to know. So it basically says immediately after identifying that now the reaction or the information given, which is now for the forward reaction, is actually for the forward reaction. After identifying that now that is exothermic, then it means the reverse must be endo. If you have identified it as endo for the forward, then the reverse must be exothermic. So be on the lookout for that. So what is important here is only to identify that which reaction is exothermic or endothermic. Immediately once you do that, everything becomes easy, because now we just check whether there was an increase in temperature or a decrease in temperature. That's the reason why in there it says a decrease in temperature in this instance, because the forward reaction is now what? Is now exothermic. So because it is exothermic, a decrease in temperature means now the forward reaction will be favored, but an increase in temperature will now be the reverse reaction being favored. So it is best, ladies and gentlemen, for one to actually consider this delta H in terms of how it goes about you identifying the delta H. Hence I said I've included another section which is not part of this at all, but it's basically more important for one to actually consider that delta H being less than 0 is not only the best way of, or the only possible way of one identifying whether a reaction is exothermic or endothermic. So we need now to clarify that. As for pressure, also very easy, increase, decrease. As we did say, the disturbance can either be increase or decrease. It says here, increase in pressure, the reaction that produces the smallest number of moles of gas is favored. So I usually write it in simple terms to say increase in pressure, increase in pressure favors a reaction with smaller or lowest number of moles. That's the reason why it says here, reaction that produces the smallest number of moles will be favored. So increase in pressure favors a reaction with the smallest number of moles. and vice versa. Decrease in pressure favors a reaction with a large number of moles, such that now we understand in simple terms what it basically means. So the one with the smallest number of moles will be favored only if there's an increase in pressure. So let's look at the example that is given. We have 2 moles of gas for the reactants and 1 mole of gas for the products. So if we increase now pressure increases favors the forward reaction. Why? Because we did say now increase in pressure favors a reaction with the smallest number of moles. So which one has the smallest number of moles? It's the product. So which reaction produces the product is the forward reaction. But now if P decreases, it means the reverse reaction is favored. What does that mean? Decrease in pressure favors a reaction with the greatest number of moles. So ladies and gentlemen, this is now the basic way of applying the Le Chatelier's principle, understanding how each factor basically influences what we actually have. So like I promised you, I will go to this particular slide before that other one. The reason for this particular slide, of which will be on your screens now, it's only because of temperature itself. We agreed that for one to explain the Le Chatelier's principle with the effect being temperature, the only best way to do that, ladies and gentlemen, is to identify a reaction being exothermic or endothermic. So this is one of the lessons I did for grade 11s, where we want to be in a position of identifying how best can one be able to say the reaction is exothermic or endothermic, because they will not always tell you that delta H is less than 0. It's not going to be that easy all the time. So the very first thing is the examiner, without saying anything in terms of delta H, one will be the reaction is a reaction in which energy is released. In the statement or the stem of the question, the examiners can easily say energy was released. So that should be a hint that this reaction was actually an exothermic reaction. The examiner can further say now energy was absorbed. The fact that now energy was absorbed without giving us any value or any information about delta H. So we can be able to associate that now with what? With now exothermic and endothermic. Furthermore, can easily say delta H is less than 0, delta H greater than 0. Or within the statement itself can easily be said that energy of the products is less than energy of the reactants. Energy to break the bonds is smaller than energy to form the bonds. So all these are critical statements that one must look for into that particular examination. The reaction vessel becomes hot. The learners were performing an experiment. They realized that the reaction vessel becomes hot. What does that tell us? It tells us that now the energy is released. When the energy is released, the reaction vessel becomes hot. When it becomes hot, we can associate that information with what? With an exothermic reaction. So when the examiner now asks us how will the yield of products be affected if there's a temperature increase, temperature decrease. The fact that we are in a position of knowing for certain with 100% assurity that now the reaction is exothermic, it basically says we can be in a position to assign that to Le Chatelier's principle in terms of the factor which will be temperature. As for endothermic reaction, energy of the products is greater than energy of the reactants. Energy to break the bonds is greater than energy to form the bonds. The reaction vessel becomes cold. So once it becomes cold, it basically says the energy has been absorbed. So if the energy is absorbed, ladies and gentlemen, that reaction we associate it as an endothermic reaction. Then it can be in a form of an equation itself or a chemical equation. Reactant A plus B gives us AB and the energy is released. That is another way of now saying this reaction energy is released. It can be A plus B plus energy, then it basically says AB is the product, but now because the energy now is on the side of the reactant, it basically means the energy was absorbed for this particular reaction to take place. And I don't think in terms of chemical equilibrium they will go as an extent of including these graphs of delta H. I don't think so. But what is critical is if it's there, because now remember grade 11 work will also be assessed. You need now to be in a position to actually be able to understand this. Inputs, Mr. Sarami.
No, about this, I've been following, sir.
Thank you very much. Inputs, Mekumalo.
I've been following. Thanks.
Thank you very much. Re a leboga sekwi. Inputs, please.
No, sir, I'm good.
Thank you very much. Tapelo.
I'm okay, sir, no problem.
Thank you very much. Then, ladies and gentlemen, with that being said, it basically says I can easily now go to this particular slide here. Let me, it looks quite clear from my view, and I can see also from my the other monitor that I'm using. Definitely it looks very nice. It says here steps when explaining in terms of Le Chatelier's principle. When explaining in terms of Le Chatelier's principle, the following steps should be used. Identify the disturbance, which is now bullet number 1. Bullet number 2, it's now state that the system will act in an opposite to the disturbance. That means now, according to Le Chatelier's principle, the system will, let me write it here. We say now, according to Le Chatelier's principle, the system will try to reinstate a new equilibrium by, very, very important. It's another space then. So you need to write that. I'm going to make it with a different example from this one to actually show you that it's going to be now an easy pattern. And then it says here, state how will the system manage to oppose the disturbance, either increase, decrease, something like that. State which reaction will be favored. Then we must say here, forward or reverse reaction is favored. You now choose, does not become complicated. And then bullet number 5, you just say now, state the effect on the number of moles of products, e.g. then it basically says the concentration of increases, decreases. You just choose. It's as simple as that. It becomes now a straightforward pattern. Maybe what I should do is for me to highlight all this. I just want to make an easy, nice, simple example for us to make it a fill in the missing words. I'm going to use H2 plus N2 gives us something like NH3. These are all gases, and for me to balance it I will need to have a 2 there and a 3 there. Now what I am going to do, it's very simple. My first disturbance I want you to follow, guys. I'm going to use it in something like purple or blue. Follow. I am going to increase this particular concentration of H2. So what is the disturbance? Write it down. Increase in concentration, increase concentration of H2. Then according to Le Chatelier's principle, the system will try to reinstate a new equilibrium by decreasing concentration of H2. It's as simple as that. Then here comes to say when it is concentration, it basically says bullet 1 and 2 has been attended to. I'm going to do it quickly with temperature for you to be able to see. Forward reaction or reverse reaction is favored. You must now choose. If we increase the reactant, it means now the system must decrease the reactant. How will the system decrease the reactant? By favoring the forward reaction to form that. So the forward reaction is favored. What will be the question? It will depend on whether the examiner asked us how will that effect now influence the concentration of NH3. Then the concentration of NH3 increases. It becomes an easy pattern. Let me duplicate this slide such that you can also have, because I'm going to also need it to explain the other disturbance that I'm going to use. So let me remove all this. I am going to change the disturbance and see now what will happen. Now I am told here that delta H is less than 0. Ne? Then the disturbance is T increases. That is our disturbance. I must now write it with blue, sorry. So this here basically tells me that forward reaction is exothermic. Then reverse must be endothermic. Or I've seen people writing it on top of the arrows for them to remember. But for me, it's easy because I know that delta H actually represents the forward reaction. And what do I know? Temperature increases favors endothermic reaction. I'm actually answering the question before doing anything else. Now let's see how will this principle assist us in terms of answering the question. The question also is, how will this effect influence the amount that of NH3? First thing is temperature increases. That is the disturbance. Then it says now, according to Le Chatelier's principle, the system will try to reinstate a new equilibrium by doing what? By decreasing the temperature. That is now when it says apply the Le Chatelier's principle by decreasing the temperature. Now that bullet that is there, bullet number 3. Bullet number 3 is then that we say increase in temperature favors endothermic reaction. It will stay like that until. Then you need to check now which one is an endothermic reaction. Is the reverse reaction? Then you tell us the reverse reaction is favored. Fine. Then when the reverse reaction is favored, what will happen to the concentration of NH3? The concentration of NH3 must now decrease. It is as simple as that. But those few important bullets need now you to follow the principle. I did not change bullet number 2. It is standard. It is as it is. It allows us to be in a position of saying we have identified the factor, but the examiner said apply Le Chatelier's principle. So for me to apply Le Chatelier's principle, very easy, ladies and gentlemen, what must I do? According to Le Chatelier's principle, the system will try to reinstate a new equilibrium by decreasing the temperature. Then bullet number 3 is basically what we understand what will happen if we increase temperature. Temperature increase favors endothermic reaction. Any questions so far, ladies and gentlemen? Oratile? Inputs, please. Thank you very much. Mr. Hloni Serame, inputs, please.
No, sir. I'm okay, sir.
Thank you very much. Then I am going to change the disturbance, and bullet number 2 will still remain the same, just to show you that the pattern, ladies and gentlemen, becomes very easy once we now understand exactly how each factor actually influences the information that is given to us. Now I am quickly going to say, fine, the examiner now tells us that the factor that is being disturbed is pressure increases. So with pressure, automatically what do we need? The number of moles. So I have 4 moles this side, and this side I have 2 moles. Mr. Sekwi?
Yes, sir. I was saying, according to Le Chatelier, sir, does it always be the second bullet you're gonna explain the same thing, but after by, sir, is it gonna differ every time?
It is going to differ every time. So check now, I just said the factor is going to be pressure increases. Ne? So obviously bullet number 1 will be pressure increases. Fine. Then bullet number 2 stays the same. According to the Le Chatelier's principle, the system will try to reinstate a new equilibrium by doing what? By decreasing pressure. Yes, so it will always be the opposite of the disturbance. Let me quickly, you are noted, Tapelo, let me quickly go to this here. It says here, when an equilibrium in a closed system is disturbed, the system will reinstate a new equilibrium by favoring the reaction that opposes the disturbance. So if the disturbance is an increase, Le Chatelier will do the decrease. That is the reason why I said now this becomes a standard operation, a standard operation of bullet number 2. Thank you very much, Mr. Sekwi. Tapelo?
So my question was, the last bullet, it will always be the concentration of something increases or decreases, even if the factor is not concentration.
The last bullet. Now, thank you very much for asking that. Let's check. Remember Le Chatelier's principle and chemical equilibria. Let me write it here. Chemical equilibria is focused now on what we call the yield. Yield is now amount. Amount is actually concentration. So you'll find questions asking about what will be the effect or what will happen to the amount or the concentration of a certain particular substance in the reaction. So chemical equilibrium is interested in the amount. Rates of reaction is interested in terms of how fast is the reaction. So the last bullet will always be, it will not come in this particular fashion. I will show you. It will be those questions of increase, decrease, or remain the same. But before you can say the answer is increase, obviously you must have your reasons. So the strategy of bullet 1, 2, 3, and 4 allows you now to make a definite decision in terms of increase, decrease, or remain the same. So immediately once you understand increase, decrease of the last bullet, it becomes easy, of bullet 1, 2, 3, 4, then it becomes easy for one to associate that question of increase, decrease. So I want to say the last bullet will actually be the one that allows you to choose which answer is correct. Because with paper 2, we have what we call negative marking, ladies and gentlemen. Negative marking basically means what? Negative marking basically means if your answer of increase decrease is wrong, we do not mark further. So it means out of the 4 marks, you are already losing the 4. So it's always best to have a system that brings you closer to increase and decrease. That gives you now at least 80% chance of the correct answer. Because now negative marking is going to be a nightmare for every one of us, because the correct answer will be decrease. When you set increase, then we don't mark further, even if your reasons are correct somehow. So it basically says we need a system that is going now to amplify our chances of getting that now 80% in that particular question. Thank you very much. Then, with that being said, we said disturbance is pressure increases. Bullet number 1, pressure increases. Write it down. It does not have marks, yes, but write it down, because it assists you to say, according to Le Chatelier's principle, the system will try to reinstate a new equilibrium by decreasing the pressure. You can easily relate to that. Now, this bullet here also must come from us now saying increase in pressure, increase in pressure favors a reaction with smaller number of moles. Which one has the smaller number of moles is the forward reaction. Then one can tick here and say forward reaction is favored. If the forward reaction is favored, what will happen to NH3? NH3 will now increase. So it just becomes a pattern that one must use. It becomes a pattern that one must always try to ensure that anyhow everything there is done in the correct manner, or the correct principles are being applied. Very happy, ladies and gentlemen. So with that being said, it means one can easily duplicate the slide, and not necessarily duplicate, just for the purpose of emphasis. Writing an expression for the chemical equilibrium Kc. It says only gases and solutions appear in the Kc expression. No solids and pure liquids are included. The equilibrium constant does not have an SI unit. Large Kc values, reaction in which the concentration of products is higher in comparison to that of the reactants. Such a reaction proceeds well to form products. I'm going to explain all this. Small Kc value, reactions in which concentration of product is low in comparison to that of the reactants. Such a reaction did not proceed well to form the products. Only temperature, I repeat now, only temperature can change the Kc value. Therefore, the Kc value is given at a specific temperature. So if we want to change the value of the Kc, that can only be done through the factor or the effect of now what? Of temperature. Kc is equals to product over reactants is not, ladies and gentlemen, it's not a Kc expression. So Kc expression, I want to put my head on the block and say it is reaction dependent. Reaction dependent. We cannot have a specific way or a standard way of writing the correct Kc expression. It will always change, forever change, depending on the type of equation you are given. So let's go back to this value that says Kc expression greater than 1, that is now bigger. If Kc is greater than 1, it basically says now the reaction in which concentration of the products is high. So we basically say concentration of products is greater than concentration of the reactants. If Kc is smaller than 1, then we basically say products are smaller than the concentration of the reactants. It is now as easy and simple as that. Very, very easy and straightforward. Basic. Writing the Kc expression, this will be 1 mark, but we'll emphasize onto it immediately when we do more of exam type of questions. But what needs to be emphasized is only gases and solutions appear in the Kc value. No solids and pure liquids are included. This is very, very, very important. So with that, it means we are going to have a bigger challenge, because now our Kc expression is going to be very, very wrong. I have had people complaining about the calculations of Kc being complex. There's nothing complex there, ladies and gentlemen. When we were doing rates of reactions, I gave you this particular slide. I am going to extend it further and say if we have the number of moles, we can get the concentration, and if we have the concentration, then we can calculate the Kc. If we are given the Kc, we can get the number of the concentration, the number of moles, and move now into this particular fashion. That's the reason why I said this approach of stoichiometry, it's not now only focused on the calculations of rates. It's actually the entire curriculum of chemistry if you want to do well in your calculations. So I am going to highlight here to say if I am given a Kc value, maybe I must just use a second also here to say if you are given a Kc value, it means you can be asked for concentration, get the number of moles. From the number of moles, use molar ratio, use now the difference to get the number of moles reacted, get the number of moles of the unknown, and then from there you just check, is the examiner asking me for mass, is the examiner asking me for concentration or pH when we get to acids and base, is the examiner asking me about the number of particles. Ladies and gentlemen, this becomes now a standard approach when we work with stoichiometric calculations. So that Kc is this thing. I repeat, the Kc approach is basically this thing. I can give you 20,000 questions of Kc, or I don't know how many, but the approach will always be the same. There's a table method that we use, that one of Mr. Ice, initial, change, and equilibrium. We are also going to use it, but as a practical example, because it's basically this. This will mean purple. This will mean initial, mole ratio. This will mean number 2. This will mean your change. This will mean your equilibrium. Yes. Initial, change, initial minus excess or something, use molar ratio, and then E is the number of moles of the unknown, which is the ice that we are talking about. So basically everything here, it's the science, it's the stoichiometric calculations that one always wanted to know of. So we are going to apply this particular principle. One will say, but questions will differ. Of course they will differ, but the principle will be the same. You will just need to find and look out for that one particular thing that the examiner is looking for. So you already have this. Let me not waste time, but I think I have explained it in detail. Now I have a question here. This one I will do, and then I will give you another one that you are going to do and discuss, so that you can see if we are on the right track or not. So let me quickly start with it. It's question 5. It basically reads as thus. It says, now initially 2 grams of pure carbon dioxide is sealed in an empty 5 decimeter cubed container. 5 decimeter cubed container at 900 degrees Celsius. Calculate now the initial concentration of carbon dioxide. Let me go back. The examiner wants me to calculate the concentration. the formula is given there as C is equals to N. So I am at 5.1. C is equals to N over V. But there's a problem now. What is the problem? I do not have the number of moles. But I can say N of CO2 is just M over the molar mass. Because I am given now what? The mass thereof. Then this becomes easy to say. This is 2 comma 2 divided by 44. This now gives us something like 0.05. Let me just clean this spot here. Zero comma 0.05 mole. Then it's easy then to say, but this is 0.05 divided by 5. The volume is already in decimeter cubed. Then this will give me something like 0.01 mole per decimeter cubed. Then this will be the easiest 4 marks that you will get. You get 1 there, 1 for the formula, 1 here, and then 1 for the final answer. And then we move to 5.2. Give a reason why equilibrium will not be established. What did we say the conditions for this particular equilibrium to be established? We said it must be in a closed system. For an equilibrium to take place, a forward and a reverse reaction is needed. Hence, we said it must be in a closed system and the reaction must be reversible. So we are not told anything there about reversible. We are not given anything in terms of the arrows. We are just told it's just pure carbon dioxide. So for dynamic equilibrium to take place, a reaction must have reverse. I'm not sure what's wrong with my pen now. Must have reverse and forward reaction. It's as simple as that. That is the reason why it is now 1 mark. Must have reverse and forward reaction. It is very clear for one to actually understand. Furthermore, now it says calcium carbonate is now added to 2.2 grams of carbon dioxide in a container, and after a while the equilibrium is established at 900 degrees Celsius according to the following balanced equation. The equilibrium constant for the reaction is given the Kc. So Kc is equals to 0.0108. No SI unit, remember that. Give a reason why the reaction will reach an equilibrium in a sealed container. Because carbon dioxide is a gas and will escape in the container if it is not sealed. Hence I said we need now to have a closed system. So carbon dioxide is a gas, it means it will escape. Now that is now 5.3. carbon dioxide will escape. That is now what we need to be looking for. Hence the closed system. Calculate the minimum mass that must be added to the container to achieve equilibrium. Now, ladies and gentlemen, let's look into this one. We said when we are given a Kc, or when we work with Kcs or Kc value, only gases and aqueous solutions. So this is a solid, it will not be part. This is a solid, it will not be part. So what does this say? It says to me at 5.4 Kc is just equals to the concentration of CO2. But we did calculate, okay, this is a new section, so it basically says now concentration of CO2 is equals to 0.0108 mole per decimeter cubed. What can we do in terms of the information given? What can we do? Very easy. One can easily say, fine, now that I have the concentration, what can I do with that particular concentration? Very easy. When I am given concentration, I'm going to go back to this. I have the concentration. I need to get the number of moles. So I'm going to go and get the number of moles. C is equals to N over V, 0.0108. I want the number of moles. The container is still 5. Then the number of moles of CO2 is just equals to 0.054 mole. But immediately after getting the number of moles, what must happen for me to link the one of the given and the one that is now not given, or the one that is asked? It is easy. I need to know now that initially I had 0.05, but now only 0.054 moles actually reacted at equilibrium. So it means I must say now N of CO2, this is now the one that has formed, will be equals to the number of moles at equilibrium minus the number of moles initial. So this is 0.054 minus 0.05. Then this will give us something like 0.004 mole. That is now this particular step I spoke about. We cannot use mole ratios as yet because we want to know the number of moles that formed at equilibrium. Then we must move. We have the number of moles. Can we use the molar ratio to link the given? Because we are given the information of carbon dioxide, but the examiner is actually asking about calcium carbonate. Then let's go here and say the number of moles of CO2 over the number of moles of CaCO3 is actually equals to, let's look into that, is basically 1 over 1 according to the balanced chemical equation. So it says now N of calcium carbonate is actually 0,004 mole. But now that I have the number of moles and the question asked about the mass, it's easy, ladies and gentlemen, to say N of calcium carbonate is just now equals to M over M, which will be now what? Which will be the mass that we are looking for. Let me do it the right way. The mass that we are looking for, and this will just be 100, 0,004, and we get now M of calcium carbonate being equals to something like 0,4 grams. Very, very, very important for us to follow the basic principles of actually understanding how these particular questions are being asked. I did not complicate things. I only used the information that is given. I followed now my strategic principles of how to approach these particular questions. Inputs, Mr. Sekwi.
No, sir.
No questions.
Yes.
Thank you very much. Input, Tapelo.
No, sir.
Thank you very much. Oratile Khumalo. Oratile. Thank you very much. Then it basically says we can easily now go into question 5.5. Let's go into 5.5, and then at 5.5 is going to be easy because we are just going to try and understand how this are going to work. How will each of the following changes affect the amount of CO? Write only CO2, write only increase, decrease, or remain the same. More of calcium carbonate is added at 900 degrees Celsius. Ladies and gentlemen, they are adding a solid. They are not adding or changing the concentration. So solids do not have concentration. So it basically says here, this must now remain the same. So the catch here is, do you understand the concept of concentration? Yes. Then it means if calcium carbonate is a solid, then it means it will not have any effect on that. So this will be just remain the same. And if it says now remain the same, let me clean it up. Remain the same. The same. The pressure is increased. And we said pressure is for only gases. So if the pressure is increased, what will this mean? It means that now the concentration of CO2 will decrease. It's basically that decreases. And the question will be why? Why decreases? Then we'll just have to consider that. We will just have to consider that when we work with pressure, we are actually either increasing the volume or decreasing the volume. So if we increase the pressure, we are actually decreasing the volume of the gas. That is basically that. It is found that at the equilibrium constant for this reaction is 2,6 multiplied by 10 to negative 6 at 727 degrees. Is the reaction exothermic or endothermic? A very beautiful question, this one. So what happens is we had now Kc which decreased. So if the Kc decreased, it basically says now, and the temperature also decreased from 900 to 727. So it basically says this reaction must be an endothermic reaction. Bullet number 1, Kc decreases or decreased with decrease in temperature. And then what does that mean? The reverse reaction is favored. Reverse reaction is favored. The last one says a decrease in temperature. A decrease in temperature favors exothermic reaction. Exothermic reaction. And that is basically it about this particular question.